leave your Chromebooks open and keep working on it. Yeah. We're not going to close it down. But I am going to go through it really quickly. In fact, listen, the assignment is open, and y'all don't be talking about kissing me while the YouTube videos are recording. It's literally about to go online, and other people will be like, what is going on in that classroom? So listen, today's assignment is called Charles Law. It's already up and assigned, and so you can get going on it if you want. Like I said, it's pretty much exactly the same as the assignment yesterday, but instead of pressure, we're talking about the difference between volume and temperature. So Charles' law states the Kelvin temperature, so remember we got to be in Kelvin again. If you're in Celsius, you got to convert to Kelvin. The Kelvin temperature and the volume of a gas are directly proportional. What does directly mean? Are they going up together or opposite? Together. So they're going to go up and down together, just like yesterday with the pressure and the temperature. And basically, just like kind of the pressure is always going to stay the same. But if my temperature increases and my pressure staying the same, then my volume kind of has to increase. And I think the example that they're going to do, the example they're going to use here is a hot air balloon. What makes the hot air balloon expand?
The hotness of the air.
The hotness of the air. And so what's in it right now is just cold air or room temperature air, whatever the temperature is outside. And then what do the hot air balloons have on them to heat the air? Somebody ever seen a video of hot air balloons? But what is it? I mean, you got to be interested.
It's a flame.
Yeah, it's literally like a giant flamethrower attached to a basket that is attached to a balloon. And so they turn the giant flamethrower on. It shoots flames into the balloon, and those flames heat up the air in the balloon, make the molecules move faster, and so they're going to hit the sides of the balloon more often, which is going to expand it up. Now, what would happen in this case is it would increase the pressure, but a hot air balloon has a hole in the bottom, and so the pressure is always going to be the same in a hot air balloon. If you increase the pressure at all, there's just air that's going to come out of that bottom hole. And so as the temperature goes up and your pressure is allowed to kind of relieve itself, the volume continues to expand. And so you can see that happening here. They turn on the flame, and then you see the heated up air start to move faster and faster and faster. The balloon expands because the air is hotter. The molecules are moving, and they're hitting the sides of the container. But because we're talking about a balloon, the container just gets bigger, and the pressure doesn't actually rise, because if it were to rise, it would just come out the bottom. Like if you just let the end of a balloon go, the pressure is going to go out the end. So that's a pretty good example there. You have to have some sort of container that's able to expand. If you don't have a container that's able to expand, this example is not going to work. So here's our formula. V1 over T1 is equal to V2 over T2. We're working with essentially the same formula as yesterday, but instead of pressure, we have volumes on top, volume 1 and volume 2. And there's really nothing to add to this. Remember, if your temperature is in Celsius, you have to change it. If it's in Kelvin, you don't have to change it. So I'm going to do these two examples real quick on the board over here. Let me just read this. A 2.4 liter volume of gas is heated from 298 to 405 K. What new volume does it occupy? So they give us volume 1, temperature 2, and they want to know what is my volume 2. So volume 1 is 2.4 liters. Temperature 1 is 298 K. Volume 2, I don't know. And then temperature 2 is 405 K. So I just plug these into the formula and solve for the one thing I don't have. So I have 2.4 over 298 is equal to X over 405. And I'm trying to solve for X. I do some cross multiplying, but what I'm going to end up doing is getting 24 times 405 divided by 298. And that's going to be equal to my answer, which is X. So multiply the top two numbers. That's a 2.4. Multiply the top two numbers, divide by the 298, and that should get you to your answer. And I believe that's what we're going to see happen right here. Like magic. Don't need to convert anything because my temperature is already in Kelvin. And then, yes, we have our problem set up just like we should. And we're solving. We see that our temperature goes up. So we expect our volume to go up. It goes up from 2.4 to 3.3. That's exactly what we want to see. Now they're going to do one more. Let's just do it on the board. A gas with an original volume of 0.213 liters increases in volume to 0.288 liters. So our volume increases. We should see our temperature increase. The original temperature was 31 degrees, so that's my temperature 1. What is the final temperature? They want my temperature 2 from me. So I'm going to come back over here and set this one up again, and then we should be good to go. So for that problem, my volume 1 is 0.213 liters. My temperature 1 is 31 degrees Celsius. I have to add 273 to that. So I actually have 304 Kelvin. My volume 2 is 0.288 liters. And then I do not know my temperature 2. That's what they want from me. So I just plug everything in. 0.213 over 304 is equal to 0.288 over x. X is what I'm looking for. So again, I cross multiply. I'm going to end up with 304 times 0.288 over 0.213 is equal to x. And so if I multiply the top two numbers and divide by the bottom number, I should see my temperature go up. Because my volume went up, my temperature should go up. So we let Sapling show us the way. They convert the temperature the same way we did, add 273. They plug everything in, and you get your 0.288 times 304 divided by 0.213. And we see that our temperature goes up from 304K to 411K. And to be honest, Sapling would probably ask for this answer to be in Celsius because they gave you a starting temperature in Celsius. So you would have to subtract 273 at the end and put that into your answer box. So I believe that's the end of the PowerPoint. It usually is after 2 examples. And so, yeah, there we go. If you have any questions, let me know. If you want me to help you set up a problem, let me know. And that's what we're working on today and probably when we get back on Monday because everybody's gone. So everybody have a nice spring break and see you when we get back.